Southern Hemi swell is tracking north. I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, May 5th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you enjoyed the video, give us a thumbs up. If you have a comment or question, write it down below. We'll be happy to answer. If you haven't subscribed, click the Stormsurf icon down in the lower right-hand corner of your screen. Get yourself signed up. You get automatic notifications when the videos are posted, typically on Sunday evenings. And if you'd like to make a contribution to the cause, you may hit the special thanks button down below, the heart with the $sign in it. With that, I'd like to thank the folks that donated last week. CV Lone Star, thank you for your very generous contribution. And then our cast of regular contributors, Tim Caston, Our Predicament, Elliot Harris, and Evolution Moto. Thanks so much for your generous contributions. I do really appreciate it. And with that, let's get to work. We'll start by looking at significant wave heights for the South Pacific Ocean. And right now, we don't have a whole lot going on, but I think that's going to be very short-lived with the series of storms forecast. But before we get into that, let's take a quick look at current conditions. We'll start in Northern California, Point Reyes. We're looking at the buoys, the Point Reyes buoy, number 029. We're looking at all the energy that's hitting this buoy, all the way out from 33.3 second period, long period energy. There's, what, a tenth of a foot, so, what, 2 inches? All the way down to 5 second period. This is just pure wind chop. We're looking at the peaks. That's where most of the energy is. We see a peak here in the 14 to 15 second period range. We see another peak in the 9 second period range. This is from a gale previously off Kamchatka, and this swell is buried in this more locally generated wind swell in about the 8.5 second period range. But rather than me guessing, let's let the computer tell us exactly what's going on. Primary swell 5.9 feet at 8.7 seconds from 293 degrees. Theoretically, that's surf at 5 feet. I think that's a bit of a stretch. It's maybe more like 4 foot. And that secondary swell 2.9 feet at 14.6 seconds from, it's probably more like 305 degrees. Okay, the wind swell kind of, you know, there's just the buoy's bobbing around a lot. It has a hard time deciphering the exact swell direction. Supposedly surf at 4.2 feet. Then we go down to Southern California, the Point Loma South buoy, number 191 off of San Diego there. Same sort of profile going on. We see a bump of energy in the 14 second range, another one in the 7 second range, something like that. Primary swell 5.3 feet at 6.6 seconds from 294 degrees. And under pretty windy conditions, that'd be surf at about waist high, maybe chest high. And then the secondary swell, now this is Southern Hemi background swell, 1.8 feet at 14.7 seconds from 200 degrees, and that's, you know, thigh high, maybe waist high surf, maybe bigger at top spots, but it's really not showing that well. And this chop height thing here, that gives you an indication of, you know, energy between 2 and 5 seconds. How lumpy is the swell? And if you got like 1 foot of lump, it's not bad. 2 feet, it starts getting bad. If you're approaching 3 feet, it's pretty much blown out. 2.9 feet as of right now, so probably pretty sloppy. And then we go take a look on the south shore of Oahu, but we're using the buoy from Lanai, number 239. It is well protected from any northwest wind swell. The Barber's Point buoy sort of picks up a lot of wraparound wind swell. And you see a little bump out here at barely 20 seconds, and then other just random, even less defined than that swell. Sort of smells of a bit of Southern Hemi swell. Primary swell 0.9 feet at 18.9 seconds from 182 degrees. That is new swell coming in from a gale over the central South Pacific. We'll get into that in a minute. But surf height 1.7 feet, so it's just trying to get going. And then there is some wind swell somehow mixed in there, 2 feet at 6 seconds, and not even really noticeable. All right, so I talked a bit about a southern Hemi swell that's starting to arrive in Hawaii, also bound for California. Let's go take a look and see what that's all about. It started on a week ago, Sunday, April 28th, southeast of New Zealand. Just a little tiny thing here, building 30-foot, well, let's actually look here. 31.7 foot seas. That's the highest seas over this entire domain, and just eyeballing it, the purple there is the only significant color we see, and that the coordinates there map up with where that is. So 31 feet on midday Sunday, building to 35 feet Sunday evening. That was a week ago. Sunday night, peaking out at 36.6 feet, and then into Monday morning, again 36.7 feet, and again 36 feet midday Monday, the 29th of April, and 35 feet in the afternoon, finally fading on Monday evening, 32-foot seas, and then fading from there. Now, another little system got organized under New Zealand right behind that with 33-foot seas. This was on Wednesday, May 1st, so, 4 or 5 days ago, lifting off to the northeast and then fading with 28-foot seas into Thursday night. And a little secondary push of energy there on Friday, making a small area of 25 to 26-foot seas. Seas here at 31 feet, all aimed at Antarctica, doing nothing for us. So, one swell from the Central South Pacific swell, our gale, another small swell, likely from the system that just pushed under New Zealand. So let's just run this out and get us up to current time. Not that there's anything to see, but there we go. For the moment, a quiet pattern. So let's go back and look at time in the North Pacific as well. There is a little bump of energy. You saw it on the Northern California buoy out in the 14-second period range. That is from a gale that developed off Kamchatka on Tuesday, April 30th. With up to 26-foot seas, right, just holding off of Kamchatka, not even really making it to the North Dateline region, which would be right here, the dateline right there, and fading out. That swell hitting California. Now, another gale developed, and swell from that also has passed the Hawaiian Islands. Another gale developed on Thursday with 25-foot seas, I think holding at 25 feet into Thursday night and into Friday, then fading with 22-foot seas. That'd be Friday, May 3rd, so just 2 days ago, and then fading out. Swell from that system, bound for the Hawaiian Islands and the U.S. West Coast as well. I mean, we're not talking any significant size, 2 feet at 14 or 15 seconds, something like that. Waist-high surf, but the Northern Hemisphere really, really winding down. The focus is on the Southern Hemi now. So with that, let's go take a look at what is forecast for the Southern Hemisphere. We're starting with jet stream level winds. These winds up about 30,000 feet help support the formation of gales when those gales form, help direct their track. We're looking for a trough, a push in the jet to the north, exactly like what we're seeing here. Okay? That helps create a clockwise flow. It creates a little eddy here in the pinch between the upward branch and the downward branch here. Creates a clockwise flow. That's the hallmark of low pressure in the Southern Hemisphere. Low pressure in the Northern Hemisphere is counterclockwise. And eventually that upper low also can manifest itself down at the ocean surface, and that creates winds. Winds, if they're strong enough, impart energy into the ocean in the form of raw seas. Those seas, as they radiate away from the fetch area, the shorter period elements of the seas fade out, and you end up with swell, and swell as it propagates towards your beach and then hits your beach turns into surf. All right, so we have a trough with potential for gale development here on Sunday. It is to push off and to the east under New Zealand into Monday. Not sure how much is actually going to evolve from that. And you see, so here's the northern branch. We have a split pattern here. Northern branch here, southern branch here. Typically in between you get high pressure. Notice the southern branch, that's the more influential one in the Southern Hemisphere from a surf generating perspective. Pushing down over Antarctic ice, the ice line I think is somewhere around 65 south. Really no support for gale development as we get into Tuesday, the 7th of May. But then another trough is forecast on Thursday. You can see it here with 130 knot winds pushing up into it. Again, supporting that clockwise flow and low pressure development and working its way up to almost a point off of New Zealand. This is a pretty solid looking trough here, continuing into Friday, May 10th, and even into Saturday, and even into Sunday, and then finally fading out 180 hours out from now. But then look at this, yet possibly another trough after that. So we'll have to see how this all plays out. But there is hope, at least in the upper levels of the atmosphere. But then we go down to the surface level pressure and surface level winds. Sure enough, we have a bit of fetch here, 30 to 35 knots under New Zealand. We know there's a trough there. And we also have this other little, you can't see it underneath the icon or the controls there, 35 knot winds pushing off to the northeast, but the whole low itself is falling southeast, so nothing's going to come from that. We get into Sunday evening, the 5th of May. This fetch kind of just fades out, doesn't look too inspirational, but we continue on as we get into Monday night, 45 knot west winds pushing under New Zealand, into Tuesday at about 40 knots. Maybe there's some hope there, but I think there's even a stronger one behind that. And here we go, Wednesday, the 8th of May, 45 knots southwest winds over a good area with a broad fetch of 35 to 40 knot winds pushing under New Zealand. That should theoretically get traction if it materializes as we get into Thursday, 35 to 40 knot southwest winds aimed well off to the northeast. That's looking good. And then continuing in some sort of fashion. Now, 30 knot winds probably isn't enough to get you a big enough sea state to not decay away to almost nothing before it reaches Hawaii and California. So hard to say. The models have been a bit all over the place, but look at this, a broad complex low with 1, 2, maybe 3 centers on Saturday. We'll have to see how that plays out. Most of the fetch looks like it's aimed at Antarctica, but yet here comes another system under New Zealand. Definitely a disturbed sea state for sure, given that it's a week out. Too early to really believe anything, but at least it appears there is hope. Let's go look at the effect of those winds on the ocean surface. So 18Z on Sunday, not a whole lot going on. 21, it says 22-foot seas right here, but that's not enough to do anything. You can get a 13-second period swell from that, but that would all be decayed before it reached Hawaii or California. So we're kind of ignoring it. But here we go. The next little system on Monday, pushing south of Tasmania with 38-foot seas. Yes, that is in the swell window for California, and maybe some energy coming up through the Tasman Sea for Hawaii. But all pretty much aimed off to the east. As we get into Monday night, 37.7-foot seas, 38 feet there for a minute. But as we get into Tuesday morning, as we really get free and clear of New Zealand, this system is already collapsing. Yes, some background swell could result for it, but it doesn't look like a great swell producer. The one behind it, though, on Wednesday, looking better with 41-foot seas. Now, even further back under the shadow here, the Great Circle path from here pretty much runs right up along New Zealand, probably cutting off Hawaii for the most part, but certainly good for California. 42-foot seas, 18Z Wednesday, the 8th of May, and then fading from 41 feet. As we get into Thursday morning, 36-foot seas pushing clear of New Zealand. Certainly seems like a good amount of swell energy will be in the pipe, shooting out the barrel here, focused on anywhere from, we'll say, Chile, Peru, certainly Central America, and up into California. That system fades out. Is there more behind it? We're looking, we don't see it, so probably not. We saw a bunch of fetch under New Zealand, but winds were in the 30 to 35 knot range. Really want to see at least 26-foot seas minimally, and preferably 30-foot seas. That'll get you a good 16-second period swell that can survive the journey in reasonably fair state to reach Hawaii and California. And just for fun, we're going to take a look here at the North Pacific, but the shorter answer is really nothing is forecast. We're looking for anything with even 20-foot seas, and we're just blasting through the next 7 days, and I'm not seeing it. I think we can put a fork in winter and say it's done and over with. Next up, the wind forecast for California here and Hawaii right here. High pressure, 1028 millibar high. Notice low pressure up here in the Gulf of Alaska, creating a gradient. This is leftover low pressure from the previous gale that was previously off of Kamchatka. Yes, that is generating wind swell. It'll probably impact the Pacific Northwest and down into Northern California, but nothing too impressive. So we get into Monday. Here we go. So this is the San Francisco Bay Area. There is Point Conception. You see winds for Northern California, pretty light out of the northwest, 10 knots, but down into, we'll say, a Big Sur southward, 20-knot northwest winds. Trades 15 knots for the Hawaiian Islands on Monday. As we get into Tuesday, gradient, high pressure starts building, and you see this building gradient over North and Central California with northwest winds 20 to 25 knots. Light trades for the Hawaiian Islands. So we get into Wednesday, the gradient builds with 30-knot northwest winds over Cape Mendocino area. But if you look really closely here, you can see, yes, there's 25-knot winds over outer waters off Central California, but near shore, not nearly as bad a situation. Hawaii, 10-knot trades. That's not bad at all. So we get into Thursday. Finally, this is like the classic sort of springtime pressure gradient that sets up. And in normal conditions, it does exactly like this. It sort of takes over the whole area from North and Central California and then lifts north, sets up this kind of weaker northwest wind flow down into Central California and even parts of Northern California. And that's what we see here. So wind swell, but with reasonably decent conditions near shore. Trades for the Hawaiian Islands, that's on Thursday. As we get into Friday, the gradient just completely fades out. Light north, probably even south winds for California on Friday. Trades 10 to 15 knots for the Hawaiian Islands. Saturday, more of the same thing. Light wind regime for California. Trades 10 or so knots for Hawaii. And on Sunday, again, northwest winds 10 knots, not bad. And trades 15 knots for the Hawaiian Islands. I'm not even going to pull up the precipitation forecast for California. There is nothing to see. There is no snow forecast. That said, yesterday, Saturday, the 4th of May, we had in the rain gauge here in Northern California, we got 1 inch of rain, which is a good amount of rain. And snow in the Sierra. I think most of the resorts are closed now. Palisades Tahoe is still open, and they got an unbelievable 26 inches of snow out of it. They were struggling to get the lifts open this morning. Long lines down low on the mountain, but by about midday, they got things open, and unfortunately, they close at 2 p.m. So maybe there'll be some snow left for tomorrow. But that brings up an interesting question. We can put the final sort of analysis on the snow forecast for this past winter season and compare it to normal. So Northern California, Crescent City, Redding, that area, pretty much anywhere from 115 to 98%. We'll say 100% of normal for Northern California. That was good. The San Francisco Bay Area here, this is for the entire season, right at 100% as well. Nice. We did okay. Now, for an El Nino winter, you would think you'd be doing more. You know, I mean, there is some readings in the 110%. And based on my local rain gauge, we're at about 110% of normal. But officially speaking, it's 100%. Then we go down into Central California, doing quite well in the probably 110% range. This is Stockton, Modesto, Fresno, that area. And some spots doing much better. And then you get into the real winner of this year's El Nino was Southern California at easily 150%, depending on where you are from, let's say, LA northward, maybe even 160% or so. And then you get down into San Diego in that area, still really impressive at 140+% of normal. So a good winter all around for the water table, for the lakes, and snow-wise, we did about 110, 115% of normal up in the Sierra. I'm sure you all have seen the official numbers from the snowpack, and even as of right now, I think they did a reading on May 1st, and right at 105, 110% of normal for this time of year. So we are in good shape water-wise going into the summer. All right, so what's the surf going to do? I mean, that's kind of why we are here. So we're going to start in Ocean Beach. We're looking at a graph. Now, this is not a very sensitive graph. It's not pulling out all the individual swells. It's just sort of the general trend along the coast. You see wind swell fading, but you see the north winds picking up on Tuesday into almost Wednesday, and we have a bunch of wind swell in the 8.5-foot range. It probably won't be that big. It'll probably be head high or something like that. Then slowly fading down as we get into the weekend. Actual swell sizes, well, today, 5 feet at 9 seconds sort of thing. You see one little reading here, 1 foot at 19 seconds. And then a bunch of 1.5 feet at 15 seconds. This is actually Kamchatka swell coming in. That'd be on Tuesday. But Southern Hemi swell is supposed to be hitting at the same time, too, from that gale previously over the South Central Pacific, building into Wednesday, but you don't see it here. The real issue here is look at all the wind swell, 8 feet at 10 seconds. You think you're going to find that Southern Hemi swell under it? Well, maybe at the most protected places, but I think a bunch of wind swell is going to be in the mix, too. That pretty much holds the whole way through the rest of the week. But we can go down to Southern California and maybe get a more protected view with the wind swell filtered out. You see surf heights in the 1.5-foot range, but building as we get into Wednesday in the 2 to 2.5-foot range, that's all pretty much Southern Hemi swell. And going on out through next weekend, wind speeds, not so bad down south once you get south of Point Conception. Swell heights, now here, still Tuesday and Wednesday, you see this, wind swell, 8 seconds, 1.5, 2 feet sort of thing. And then all of a sudden the Southern Hemi swell pops out on Wednesday. It starts to dominate 1.5 feet at 15 seconds. I mean, that's good for 2, 2.5, maybe 3-foot surf sort of thing. And continuing the whole way through the weekend, and more New Zealand swell filling in after that. Then finally we go look at Oahu, south shore of Oahu. 2-foot surf sort of thing, building to 3 feet as we get into Thursday and Friday of the coming week, with trades for the most part in the 10 to 15 knot range, not too horribly bad. Swell heights, you can see the bits and pieces of Southern Hemi swell. In fact, the beginnings of that South Central Pacific gale swell hitting now at 1.4 feet at 17 seconds. Then the wind swell sort of mixed in there. But you get little hints here every now and then of the Southern Hemi swell. And then New Zealand swell on Thursday showing up in the 2 feet at 17-second range, working its way down as we get into the weekend. All right, let's go take a look long-term. What's going on with the MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation. These two oscillations are the major contributors to variability, be it either good or bad, in the North and South Pacific, and have major influences on swell production. So we start by looking for signs of the MJO, the Madden-Julian Oscillation. It actually comes in two flavors, an active phase and an inactive phase. They oscillate around the planet, one on one side of the planet, the one on the other. They rotate polar opposite each other on the equator, west to east. The active phase of the MJO is a low-pressure system. The inactive phase, like a high-pressure system. The active phase is the good one. It takes warm, moist air from down on the equator in the West Pacific, lifts it aloft. That energy eventually gets fed into the jet stream. It energizes the jet stream, be it either in the northern hemi or the southern hemi. And that in turn helps create troughs, which help create storms, which help create surf, and then in winter months, snow and precipitation. All right. The inactive phase does the opposite. It's a high-pressure system. It cuts off the moisture flow up in the upper levels of the atmosphere. The jet stream, the storm production machine falls asleep, and high pressure takes over the Pacific, which does nothing for swell production. All right, so The active phase, what it also does is help dampen trade winds. So we're looking at data from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. West Pacific here, East Pacific here. This is the equator right here. That is New Guinea there, and Ecuador is off somewhere on here on the side. We're just looking at the arrows. These are 5-day average winds from the buoys. Yeah, winds sort of, they fluctuate during the day and night, and they change direction based on thunderstorms and local weather patterns, but a 5-day average gives you sort of a sense of what's going on. We see winds, longer the arrow, the stronger the wind, so moderate to strong out of the east. Trade winds, no big surprise, and it's summer. Over the central Pacific, Hawaii is about 156, 158. West, still pretty long arrows, moderate to strong trades, and over the West Pacific, moderate to strong trades. But it's not the actual wind speeds that matter so much. It's the anomalies, the difference from normal for this time of year. Looking at the arrows, yeah, we see trades, the arrows, just little baby arrows out of the east, so trades a little bit stronger than normal over the East Pacific. You get to the Central Pacific, the arrows aren't even hardly present, so normal winds, same thing here over the West Pacific. No arrows, though, that are reversing direction, suggesting that the active phase of the MJO doesn't appear present here. But the good news is the inactive phase doesn't appear too present, except maybe over here where the trades are a little bit stronger than normal. So pretty much a neutral pattern over the all-important West Pacific. That's where, when the active phase is here, it does its magic, feeding energy to the jet stream, which feeds the storm pattern. So what's the forecast for the next 2 weeks? This is 850 millibar zonal wind anomalies right there. What does that mean? Are the winds blowing stronger out of the east or stronger out of the west than normal? Winds stronger out of the east mean the inactive phase of the MJO, meaning not good for storm development. The opposite, westerly anomalies, is what we want to see associated with the active phase of the MJO. The blues on this chart are easterly anomalies, stronger than normal, inactive phase of the MJO. The reds are westerly anomalies, the active phase of the MJO. But this is the whole planet on one chart. So 180 west, that is the date line. So that's smack in the middle of the Pacific. The far west Pacific on the equator starts about 125 east, so right here. And the all-important west anomalies over the Kelvin wave generation area, over the West Pacific. So the sweet area starts here the whole way up the chart, goes to about here, 170 west. So you can see, this is past performance here. You can see the dates. You see easterly anomalies traversing the Pacific, inactive phase of the MJO. Not good for surf production. But then pretty much starting right today, you see the beginnings of westerly anomalies creeping into the West Pacific. You can see them working their way across the Pacific over the next 2-week period. So it looks like we're moving from the inactive phase of the MJO here to the active phase of the MJO. So this would be a good sweet spot for storm production. All right, another component of the MJO is clouds, right? If you have low pressure over the Pacific and it's drawing warm, moist air aloft, that would be the active phase of the MJO. That warm, moist air eventually is going to hit cold air in the upper levels of the atmosphere and condense, forming clouds. So this is a model. They call it outgoing long-wave radiation. The idea being if you have sunlight and it's bouncing off the ocean surface and reflecting back to satellites rotating around the planet, then that is a sign of high pressure. High pressure gives you cloud-free air. Low pressure does the opposite. It creates moisture or lifts moisture aloft and creates clouds. So the blues are cloudy skies, synonymous with the active phase of the MJO. The oranges are cloud-free skies, dry air, inactive phase of the MJO. And this is South America, Central America, Hawaii, New Guinea there. EQ is the equator, the date line right up the middle. So it looks like the active phase of the MJO is building over the Kelvin wave generation area, the West Pacific. Now, this is a statistic model. It suggests that 5 days from now, that active phase continues in the West Pacific, kind of falters 10 days from now, and then 2 weeks from now, sort of regroups and regets its footing with the active phase rebuilding in the West Pacific. That is a pretty good sign. Now, Now we have a contrary model, the GEFS model. The GFS model, but it's an ensemble model, but it's basically painting some version of the same thing, but with 15 days out the active phase, kind of retrograding and diving back over the maritime continent almost into the Indian Ocean. So a little bit of a disparity between the statistic model and its rather rosy picture of the active phase in the West Pacific, the dynamic model with the active phase retrograding back to the west. All right, these are phase diagrams for those same two models, statistic model here, dynamic model here. This might help us understand at a little bit deeper level of detail why those previous charts showed what they showed. Now, how do you read this chart? Well, this just tracks where the active phase of the MJO is, and we know the active phase moves from the Indian Ocean to the maritime continent, to the West Pacific, to the East Pacific, on the equator, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. The heavy dot is where the active phase is right now, and the further that dot is away from the circle of death here in the center, the stronger the active phase is. So it's really close to the circle. So weak active phase over the maritime continent today. 2 weeks from now, we've got 1, 2, 3 different models, 3 different runs of that model, if you will, under different conditions. 2 of them put the active phase smack in the West Pacific, but very weak 2 weeks from now. The third one shows it retrograding back to the maritime continent. The GEFS model shows pretty much the same thing as this one. The active phase making it to the West Pacific, but extremely weak, maybe even just like 5 or 6 days from now. And then you can barely see the green line, it wandering around, making it back to the maritime continent 2 weeks from now. So actually one of the members of the statistic model is pretty much in sync with the dynamic model. So a 50-50 split. Another upper level model showing areas favorable for precipitation, the greens, wet air, the oranges and reds, or the reds and yellows, or oranges and yellows, dry air. All right, and let's get ourselves oriented here. South America, Central America, the maritime continent, Bali, New Guinea there, and Africa over here. So dry air over the Atlantic today, with the active phase of the MJO moving in the West Pacific today. 5 days from now, active phase filling the Pacific. 10 days from now, filling. 15 days filling, but starting to move off to the East Pacific, while the inactive phase gets itself organized, starts pushing into an over the Kelvin wave generation area by the end of May, pretty much taking control of the Pacific through, this says to June 14th, but you get the sense another weak little active phase, maybe trying to nudge into the Pacific 40 days from now. But if anything, this area right here from now till about mid to late May, and this runs about 7 days ahead because this is in the upper levels of the atmosphere, jet stream level. What happens at the surface is 5 to 7 days behind that. So from now to, we'll say, the end of May is probably a sweet spot for storm production in the southern Hemi. And we have another model, the CFS model. This goes out a month. This actually can show you, rather than trying to infer where the active and inactive phases are, you can see it here. In fact, we'll hear it. MJO, the black contour. The dotted contour is the inactive phase, the blues, easterly anomalies. So you can see, oh, and this is the same deal, the whole planet. So the date line runs right up the middle. So our sweet spot starts about 125 west here to about 170 west here. Past performance, you can see inactive phase here in February and early March, active phase in March with the oranges and reds, westerly anomalies, a weak inactive phase in March and early April set up. You could almost guess that maybe there was a weak active phase somewhere in here. Currently, though, here we go, May 4th. Here's our current weak inactive phase with easterly anomalies transiting across the Pacific. But the beginnings of the active phase, May 4th, setting up in the West Pacific. Forecast to really start getting traction in earnest about a week from now with westerly anomalies transiting across the Pacific into almost the 23rd or so of May. So here is our sweet spot again. We'll say May 10th through May 20th. Okay, and then after that, easterly anomalies. And then the same model, the CFS model, but going out 3 months. This is past performance at the bottom. The forecast is at the top of the chart, okay? But the same deal. It's the yellows and oranges are westerly anomalies, the blues, easterly anomalies. The date line runs right up the middle, so our sweet spot starts 125 east, so about here, through about 170 west, right about here. We're looking at the top here. Now, the interesting thing about this is you can see, here's our easterly anomalies, and you just see this starting to glare really obvious. A building area of easterly anomalies from, where is that? The date line on East California is at 120 west. So basically the entire eastern half of the Pacific getting dominated by easterly anomalies. That means high pressure. That's not atypical for this time of year, but you see westerly anomalies here at the date line. If anything, they are retrograding off to the west and becoming more focused over the maritime continent. That is not what you'd want to see if you're in some sort of you think you're trying to move towards a building El Nino pattern, but we know that that is probably not the case. If anything, we're building into La Nina. Let's overlay the MJO first and see where we're at. All right, so here is our inactive phase of the MJO here, the dotted contour. This is past performance here. I'm just ignoring that. But this even says within the next week, even though we're in the inactive phase of the MJO, westerly anomalies start building, associated with a weak active phase that really starts showing up May 13th and continues into about the end of May. Okay, so that's consistent with what we saw at the other models. This is maybe a little bit delayed behind them. Another weak inactive phase, and then a weak active phase, but there begins to be no correlation between active or inactive and the easterly anomalies and the westerly anomalies, and they all just start getting shunted off to the west. Why is that? Well, that's probably because of the low pass, not because of the low pass filter, but the low pass filter clearly identifies why that is happening. The solid contours, low pressure bias. Think of it as the El Nino signal. 1, 2, 3, 4 contour lines here on the date line back January of this year. This was our El Nino, and you see it fading, only one contour line left, and that pretty much collapsing here in the next 2 to 3 weeks, something like that. You also see the dreaded dotted contour, the black dotted contour line. This is high pressure as of today, starting to build in the far west Pacific. And as we get into June, it filling pretty much the bulk of the Pacific. This is the building La Nina signal. And to make that even more, sort of put an asterisk on it, you see the low pressure bias. During an El Nino, the low pressure bias sets up over the date line. Now you see during La Nina, the low pressure bias setting up over the maritime continent and the high pressure bias setting up over the Pacific. The yin and the yang. They switch back and forth every 5 to 7 years, something like that. So we had our El Nino. I don't know that it was a complete El Nino. We're going to do this wrap-up. We've talked about this for a while, and I'll talk about it here for a little bit more. We've talked about the PDO and its effect on all this. I've been trying to think about how to do this. I think what I'm going to do is an El Nino wrap-up and then talk about the effects of the PDO on this past year's El Nino and why it didn't do what the El Nino did well and what it didn't do well at, and just some of the talk around that. So that's rather than going into all this detail 1 week, we'll reserve a good chunk of maybe 15 or 20 minutes to go through a recap of El Nino and the PDO. All right, so we've kind of beat the MJO thing to death, but let's go talk about El Nino and the ENSO, El Nino Southern Oscillation, and a bit about what's happening in the ocean as it relates to the transition from El Nino to La Nina. All right, so the first thing we're going to talk about or analyze is subsurface water temperatures. This is data, again, from the TAO buoy array. These are the actual anchor lines on those buoys. The X's are sensors strung down the anchor lines. The anchor lines collect water temperature, subsurface temperature data. This is down 100 meters, 200 meters, the whole way across the Pacific. This is the East Pacific here, West Pacific here. What that does is gives you a view of, they call it the thermocline, the difference between warm and cold water, but it sort of tells you where the balance of warm water is. During El Nino, the balance of warm water pushes to the East Pacific. During La Nina, trades build, take all the warm water and scrape it off and push it into the West Pacific. You can pretty much clearly see that trend on this chart. The 29 degrees Celsius isotherm right here, pushing east to about 169 west. I think that's where it was last week. 28 degree isotherm, maybe it's made no change really, right at about 140 west. Now you do see the 28 degree isotherm has deepened a little bit here in the far East Pacific, but at the end of the day, that's not because of a Kelvin wave or anything. That's just the sun beating on the ocean here, warming it up a little bit. The 24 degree isotherm, that's sort of the dividing line between cold and hot water, pretty shallow here in the east and then getting progressively deeper in the west, suggesting warm water is all here in the west, suggesting a transition from an El Nino pattern to a La Nina pattern. But it is, again, not the average temperatures, it is the anomalies. Difference from normal for this time of year. Yes, you can see that little bit of warming here on the surface from the sun, but you also see massive amounts of 3 to 4 degree below normal temps there, and 3 degree below normal temps here. This would be Ecuador somewhere over here, so pretty much filling the whole subsurface Pacific, putting upward pressure on whatever warm temperatures are here. You know this cold water is going to start erupting if it isn't erupting already, and trades at some point will start building stronger than normal, sweeping whatever warm water is left of El Nino off to the West Pacific. We have another version of that data, same data source from the buoys, but also with satellite data integrated with it. And you can see here clearly actually cold water erupting to the surface off of Ecuador. And the last of the weekly warm water from El Nino, nowhere to be found in the East Pacific, getting slowly pushed off to the west by trade winds. You see the building warm pool in the west. As the trades build and build, warm water will continually get scraped off to the west, and this will just sit here and fester for a couple of 3 or 4 or 5 years, depending on, and whenever the atmosphere decides to, that there's too much warm water here, and then the dam breaks and it all starts flooding off to the east again, and we go into El Nino. This is the satellite data version used to map the height of the ocean surface. That is, you take here's the Earth, you have a satellite, a polar orbiting satellite rotating around. The Earth spins around underneath it. The satellite doesn't move, and over the period of about a week, it maps every square inch of the planet's oceans. What it's looking for is you strip out the waves, the wind waves, and the tides, and it tells you the sphere of the ocean, is it higher or lower than normal. Why would that be? Well, if you have cold water at depth, cold water contracts, right? And that'll create a divot on the ocean surface. The water above the cold water pool will sort of collapse. Likewise, warm water at depth expands. It'll displace whatever water's above that upward, create a bump on the ocean surface. So let's get ourselves oriented here. Chile, Peru, Ecuador, Central America, right up there. Here's the equator, here's the dateline, Hawaii is hanging up here, New Guinea over here. The message from this picture, and all we care about, is 5 degrees north and south of the equator. So that's 10 north, that's 10 south. So this band between there and there, and maybe sometimes only 3 degrees north and south. You can see it plain as day though here. Here's the Galapagos, here's Ecuador, -5, -10, -15. Negative anomalies here, suggesting a depression on the ocean surface, suggesting cold water at depth, exactly like what the TAO buoy array is telling us, saying cold water building almost from the dateline the whole way into Ecuador. This is subsurface though, okay? So this is not yet manifest itself on the ocean surface, but this is the beginning of the La Nina machine becoming evident in the data. Upper ocean heat anomalies, you can see this here. This is a good picture. West Pacific here, East Pacific here. You can literally see the pulses of warm water. This was June or May of last year. This is the beginnings of our El Nino. It takes a year for El Nino to really get going. You can see the Kelvin waves produced by strong active phases, the MJO, and westerly anomalies associated with those Kelvin waves, creating west winds on the ocean surface, pushing the warm water pool that was in the West Pacific off over to the east across the Pacific. You see it building off of Ecuador here. 1, 2, 3, 4, almost 5 Kelvin waves in this picture. I think there was a total of 9 that got us to this year's El Nino. But then the machine cut off. You see there was no more warm water in the West Pacific. A cool pool emerged, and now we are in a cold water Kelvin wave. 1, 2 at least in control right now, and likely many more before we get to winter of this year. Then we go to the sea surface temperatures. Subsurface, it clearly looks like we're fully in La Nina. From an MJO perspective and the pressure gradients in the atmosphere, it looks like we're right at the cusp of moving fully into a La Nina pattern. And remember, it's not just about what's happening today. It's a trend over months and months. We've been in a El Nino trend that has kind of blown its top now. We clearly see signs of La Nina subsurface in the ocean, but on the ocean surface, so here we go, Chile, Peru, Ecuador, Central America, Hawaii, the equator roughly here, the Galapagos right there. The oranges and red, this is sea surface temperature anomalies. So we see warmer than normal temperatures off of Ecuador the whole way across the Pacific. This is all the hangover from El Nino. El Nino has been very active. It doesn't turn on it's more not like flipping a light switch. It's more like turning down the dimmer. And the dimmer is coming down, and the warm waters from El Nino are still present, but they're fading. And the real obvious sign is this cool pool right here developing. This is the beginnings of that cold water that we saw down deep in the ocean, starting to emerge to the ocean surface, extending from about 105 west, so that'd be like central Mexico, the whole way out to almost Hawaii. And the expectation is over time, this is only going to get bigger and bigger, and as it does, this warm water that's all surrounding it's going to get less and less and less. And you can already see the building warm pool at the surface developing here. It's just a matter of time for the last hangover remnants of El Nino to get swept out of the picture. Temperature trend for the past 7 days, so not as bad as last week, but you can still see, so here's Chile, Peru, Central America, the equator's right here. Blues, cooling waters for the past 7 days along Peru, up to the Galapagos, out to somewhere south of California. Now we also see a little pocket here of warming temperatures, and that's when you looked at the two subsurface charts. You saw one showed cool water erupting off of Ecuador, the other showed warm water, and it's really split because remember it's 5 degrees north and south of the equator. So depending on how you parse it, just north of the equator it's warm water, just south of the equator it's cooler water. Either way, it seems like whatever's happening here, this is probably more the effects of the lack of trade winds and just the sun beating on the ocean surface, doing some local warming, where this cool signal here is the deep subsurface cool pool leaching to the surface. It will take over at some point and fill this whole area. But remember, this is just a 7-day trend, so kind of a mixed pattern for the 7 days. Then here's the backed off view. Again, same sort of deal. Warm temperatures around the emerging, developing cool pool, La Nina, poking its nose through, not in control yet. We're in that transition. We're still in the hangover of El Nino, but La Nina's going, I'm here. I'm going to make myself known, but not too strong yet. Wait till about July or so. We think it'll be a different picture by then. All right, sea surface temperature trend in the Nino 1.2 region. This is right there by the Galapagos. Remember, we saw a little bit of warming water on the 7-day trend. You can see that showing right here. But actual temperatures for today, -0, 70 thousandths of a degree below normal right there, but basically hovering around normal for the past week. But you see, we were definitely the first little hints of La Nina developing here in the latter part of March and pretty much all the way through April, coming down off the highs, and we were even higher back when we were in January. So you see the downward trend here. Now, the official El Nino monitoring region, the Nino 3.4, this is on the equator on a point south of California out to about the dateline. The steady downward trend, today's value, 299 thousandths of a degree above normal. Still in El Nino, but just barely. This is that push and pull between the developing cool pool and the lingering warm water on the equator there. Still, the balance goes to warmer than normal water, but once you get below half a degree, between half a degree above normal and half a degree below normal, it's just considered normal. From half a degree above normal to 1 degree is weak El Nino if it's there for, 3 months, 5 consecutive 3 months periods. The moderate El Nino from 1 to 1.5 degree above normal, and strong from 1.5 to 2 degrees. And we were in a strong El Nino. In fact, let's go look at just what the data shows. This is the weekly data. This is the Nino 1.2 region here, Nino 3, Nino 3.4. This is the official El Nino monitoring region, Nino 4 out here. For the week of May 1st, our sea surface temperature anomaly was half a degree, 0.6 of a degree above normal. And you can see the downward trend. Here we were peaking back in November, 2.1 degrees, 2 degrees, 2 degrees in December. And then from January, it's been a slow, steady downward trend. Once you get to half a degree, and this is pretty much, it seems like we're there, then we're in neutral territory. Let's go look at some other data. Here is the monthly data for the Nino 3.4 region here. So, in October, plus 1.72 to 2 degrees. Here's our peak in November and December, both at 2.02 degrees. Strong El Nino, and then fading in January, February, March, April down to 0.8 of a degree. Now, this is for a whole month, right? The other was weekly data, so this is going to lag behind. Then we do the seasonal data. This is for 3-month periods, the ONI index, if you will. So this would be July, August, September, October. You see the temperatures building here. September, October, November, 1.78. October, November, December, 1.92. November, December, January, 1.95. This is a peak of our El Nino. And now we're doing the slow decline at 1.15 degrees for February, March, and April. So definitely on the downward trend for El Nino. So what does the atmosphere think is going on? We can tell by looking at the Southern Oscillation Index, the difference in pressure between Darwin, Australia here, and Tahiti. Tahiti in the Pacific, Darwin's over the maritime continent, more or less. When pressure is lower over Tahiti, the index goes negative. When it's higher over Tahiti, the index goes positive. Today, the daily contribution, 7.37 degrees. So weekly positive. Looking back down this column for the past month, well, we went from minus 18.32. I mean, that's just a single day reading, but you kind of get the sense that the trend is heading upward, heading towards pressure being higher over Tahiti than Darwin. We saw that in all the charts. It's not surprising. The 30-day average, just an average, all this data, so you can pick out the trend a little bit easier. Minus 3.66 today. Where were we a month ago? Probably, we haven't gone anywhere. Minus 2.76 a month ago. So still just kind of floundering around. Now, we've talked about this in the past. You've seen it too. The SOI did not do well for this El Nino. The numbers did not look good. Again, we think that's related to the PDO and high pressure in the South Pacific. 90-day average Southern Oscillation Index. Well, we'll go out a little bit further and see minus 5.45 and minus 4.46. It's not going anywhere according to this. I don't think the Southern Oscillation Index is necessarily a great indicator of what's happening for this El Nino. But let's go look at the data graphed out. Here's the 30-day average on a graph. Again, here was our La Nina. Here's the zero line. If you're above it, you're in La Nina. If you're below it, you're in El Nino. We see our big La Nina back in April of 2022. And then we got into January of 2023 last year, and you see just this massive fall. The pressure went from higher in the Pacific to lower in the Pacific relative to Darwin, Australia. But then right when our El Nino should have been, really building solidly in July, the Southern Oscillation Index just died. Don't know what happened. Tried to regroup, but basically El Nino lost momentum. When it did come back, it was sort of a shadow of what it was. And by January this year, we're in neutral territory. Little pulse here back in, February, but here we are now. The general trend, you can kind of draw a line through this. It's heading upwards, just like you could draw a line downwards there and a line flat across here. So El Nino fading out. The forecast for sea surface temperatures in the Nino 3.4 region, the official El Nino monitoring region, as rendered by the CFS version 2 model. Well, there's our peak over our El Nino. This is neutral right here. Our peak 2 degrees above normal in the, November time frame, November, December. The solid line is actual temperatures, so we're down here at, what's this get us to? About 0.6 degrees as of, and this is the middle of April, so the end of April. By mid-May, at dead even. And from there on, it's a downward trend. Now, the good news is today's run of the model actually has moderated a bit, suggesting temperatures going down to maybe 1.6 degrees below normal in November. Previously, it was down at 1.75. The PDF corrected version of that model has also the same trend. Temperatures coming up a little bit at minus 1.4 degrees. They were down at minus 1.45. But either way, La Nina on the way to developing. So for right now, things are looking pretty good in the Pacific. The jet stream looking healthy coming under New Zealand, not over the top, but we know we have one gale that developed over the south central Pacific that has swell pushing north. It is now just starting to hit Hawaii, bound in for California Tuesday, Wednesday, Thursday, Friday, Saturday kind of thing. So rideable surf, bit of wind swell in the mix early in the swell, but then that wind swell quickly fades out as the gradient pushes to the north, and things should clean up for most of the California coast. Another gale pushed under New Zealand. Swell from that expected, by the weekend, late weekend, early part of next week. Maybe not quite as big as this central South Pacific gale, but still rideable surf, maybe focused more on California, but some action for Hawaii. And then the model's looking good with a series of gales forecast under New Zealand. Now, do we believe a model a week out? No, of course not, but at least it gives us some hope. We'll have to watch the models. You can look at those models on Stormsurf, watch their progression, the storm's progression, what's suggested will happen over the coming days until we do this video again next week. Now, long term, clearly moving towards a La Nina pattern. The strength of the La Nina really still to be determined. We're in the spring unpredictability barrier. The models have a hard time because the atmosphere hasn't quite figured itself out either. But as we get into the beginning of June, I think the models will stabilize, and then we'll have a better sense, are we going into a moderate or a strong or a super strong La Nina? If you have an opinion on that, be sure to give us a comment and let us know. I know what I know, but sometimes you all know a little bit more than I, or have a different take and a different perspective. I'd be happy to hear it. But beyond that, so precipitation for next winter. Typically the year after an El Nino winter, so the winter to come. We're talking the forecast a year from now almost. Sometimes the snow does really well in the Sierra, and we get rainfall. Even though you're in a La Nina, the hangover for El Nino is still in the upper atmosphere. It drives. There's definitely a lot more moisture in the atmosphere than normal, driven by El Nino, but also driven by the Tonga volcano a couple of years ago. So we're hoping that maybe we'll get one more year of hopefully normal snowpack and or close to normal precipitation in California. But pretty much after that, I expect a couple of years of drought to follow. The interesting thing about this is you can make those predictions with, 70% certainty if you follow these sort of patterns and if you've been doing it for decades. So we'll see. I could be right, could be wrong. Who knows? But for right now, surf is on the way. Take it, make the most of it. Our red X here, or our good window for surf, is probably starting a week from now going through the end of May. Then after that, we're going to go into a bit of a slump. If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of the screen. And if you'd like to make a donation to the cause, you can. Click the special thanks button down below, the heart with the $sign in it, and we appreciate your donations. With that, we are done for this week. We will do it again next week, same time, same channel. Thanks for watching.